Hey everybody! So, me and Maggie were both environmental engineering students, and we thought what would be an intersection between environmental engineering and electrical engineering. So, for this project, we designed a device that would measure all the parameters of the plant. For example, the temperature and humidity, the soil moisture, the lux, and the pH of the soil. And we called our project like the plant optimizer because then we can measure those values and optimize them. So we would increase the longevity of the household plants. And therefore, as you all know, plants perform photosynthesis, which means they take CO2 from the atmosphere and produce oxygen. This is important because with the increase of the longevity of household plants, we would increase the uptake of CO2 from the atmosphere into the land biota, and therefore we would observe, even just by a little bit, a small decrease in CO2 concentration in the atmosphere. So let me show you what we've done. This is our circuit diagram. As you can see, on the top left, we have the DHT11 temperature and humidity sensor. The ground input of the sensor is connected to the ground of Arduino. The data is connected to pin 2 of Arduino's, and the VCC is connected to the VCC on the Arduino's board. On the top right, we have the lux sensor. In the lux sensor, the Vin is connected to the VCC of Arduino, and the ground is connected to Arduino's ground. In the lux sensor, we have two data outputs, the SCL and the SDA. Both are connected to pin 11 and pin 12 of the Arduino, which are also known as the SCL and SDA pins. On the bottom left, we have the soil moisture sensor. As you can see from the diagram, the ground of the soil moisture sensor is connected to Arduino's ground. The VCC is connected to the VCC of the Arduino, and the signal is connected to the analog pin of Arduino A0. On the bottom right, we have the pH sensor. The V+ of the pH sensor goes to the 5 volts on Arduino because the pH sensor operates in between 0 and 5 volts. The ground of the pH sensor goes to Arduino's ground. The P0 of the pH sensor, which is the data output, is connected to the A1 pin on Arduino. We created a voltage divider because the pH sensor, as I mentioned earlier, operates between 0 to 5 volts, while the Arduino only operates between 0 to 3.3 volts.
Before adding the voltage divider, here we see the voltages we got on the serial monitor after reading the analog pin volt and converting it to volts. So using the waveforms, we see that the voltage was actually 2.5, but the serial monitor was reading a voltage of 3.85. And we didn't know why that was the case. After adding the voltage divider, we shorted the BNC connector, and then when measuring the voltage from the A1 pin, we were getting the correct voltage, which corresponds with a pH level of 7. We prepared a pH of 4.01 buffer solution, and then we inserted the probe into it to measure the corresponding voltage change in the serial monitor. With the two known pH values and voltage values, we were able to create a linear regression model in order to calculate the voltage from pin A1 into the corresponding pH level using the equation in line 11.